Okay, Trig, we're to the end of the chapter. We're starting review. I'm not sure if I left, or if you guys have this in your binder already of all the chapter 3 stuff, but I left a copy of this with my sub also. I think it's Mr. Johnson. So make sure you get that from him. But I'm going to try to go through, there's like 33 questions on this review. It's just a front and back. I'm going to try to go through like one problem out of each kind of section, and then maybe hopefully you can kind of try to figure out some of the other ones, and then we'll go over any questions that you have tomorrow. So we'll kind of do it that way, but let's just like look at each heading. So this one right here is talking about one-to-one functions, okay? One-to-one functions mean that the original guy is a function and his inverse is a function. So when you're looking at like ordered pairs right here, you want to make sure the x's don't repeat in order for the original to be a function, but you want to make sure that the y coordinates also don't repeat. Okay, so that's that. All right, so let's go with number 3, because you guys can probably figure out 1 and 2, but let's go with number 3, where we're looking at this guy, right? 4x squared. And so what I'm going to do is I'm going to think about him in terms of what he looks like as a graph, but I need to know what he looks like according to his parent function. So parent function is an x squared, and he's positive, so he's going to do a parabola, something like that, right? So if I'm looking at the original being a function, I'm going to see, does he pass the vertical line test? Well, yeah, check. That one is okay. But in order to see whether the inverse is a function, I'm going to see whether he passes the horizontal line test. Okay, he does not pass the horizontal line test because he's going to touch at more than one place for each horizontal line. So his original is a function, but the inverse is not a function, so he is not one-to-one. Okay, all right, so you can try to figure out what 1 and 2 are going to be based off of that. We've got, let's go with number 4 when we're finding inverses, okay? So finding an inverse, there are 4 steps, and some of you guys skip the first 2 kind of steps-ish, but step number 1 is you rename f of x and you call it y, and then x and y switch places with each other, okay? And then the third step, which is the hardest one, is where you need to solve for y. And then step number 4, the y gets renamed as f inverse of x. Okay, and if I'm going too fast through these, just feel free to pause or do whatever you need to do. Okay, so all right, here we go. F of x becomes y, and then switch x and y. So I'm going to do that. This guy is now y, but I'm going to switch him, and he is actually going to be my x coordinate, and this guy's going to be my y coordinate. And now I want to solve for y, so I'm going to get this y by itself. Okay, so I'm going to move all of this other stuff over here on this side. And what I'm going to move, first is I'm going to subtract this 3. Okay, so over here I've got x minus 3 equals the square root of y minus 2. And then the next thing that I have to move is I've got to square both sides. Okay, and that gets rid of the square root. So this y minus 2 is just going to fall out of there. And I'm going to leave that. I'm not going to FOIL that out or anything. I'm just going to leave that as x minus 3 squared, okay? And the last thing I have to do to get y by itself is add the 2 over. Now, I cannot add this 2 to this 3 because that one's inside of the square. So I'm just going to write it as x minus 3 squared plus 2. That doesn't look like a z. That's a 2. Equals y. And then my last step is rewriting, and I'm going to switch these 2 guys places. I'm going to call that f inverse of x equals x minus 3 squared plus 2. Okay, and that is a quadratic function, like x squared and the square root of x. Those 2 guys are inverses of each other. They undo one another, so that kind of makes sense. Okay, all right, so you go ahead and try to do example 5. And it's the same 4 steps, okay? Example 6 doesn't have a pair to go with him, so we'll just do this one together. But it says use composition to determine whether or not the functions are inverses. So composition is that f composed of g, and then we're also going to do g composed of f of x, okay? And so when we do that, like g for this problem is going to be the inside function. So I'm going to stick g into f. I'm going to stick this g function into f where that x is, okay? So it is 3x minus 1, and in place of that x, I'm going to put x plus 1 over 3. Okay, and then we have to simplify, right? So this is like 3 over 1 times that. Well, these 3's can cancel. Okay, all right. So now I have x plus 1 right here, right? And then I've got minus 1. and that comes out to be x. Okay, we're off to a good start, right? In order for these to be inverses, they have to both simplify to be x. So I'm halfway there. We're pretty good to go. Let's now do the other way. So I'm going to stick f of x into g of x. So this whole guy is going to now go in for just that x, right? So instead of this being x plus 1 over 3, we're going to do 3x minus 1, okay? And here, these parentheses aren't doing anything. So I'm just going to break them down. I'm going to do minus 1 plus 1. Those can cancel. And now I have 3x over 3, which is just x. Perfect. So what does that mean? F and G are inverses. Okay, those two things are inverses. They undo one another. Okay? All right, next. Let's do 7 or 8. Which one? Let's do 8. Let's do 8 together. Okay, so our parent function is 3 to the x power. That's an exponential function. So all we have to do is figure out what the plus 4 is doing and what the minus 7 is doing. Okay, the plus 4 is going to move him to the left 4 because it's the opposite sign of what you think, right? Like this is kind of like where my parentheses live. So plus 4 actually means left 4. This minus 7 is going to move him down 7, and that's all we need to do, right? List the transformations. So if I start with 3 to the x power, 3 to the x power is that exponential function that goes through here and he crosses at 1. I just need to move him to the left 4 and down 7 and graph him, and that's what he will look like, okay? All right, let's do, I don't know which one of these I want to do. How much carbon-14 remains? If the population now, I don't know, compounded continuously. Okay, we'll do number 9 together because that one's like a double problem. Okay, and then you should be able to figure out number 10 and 11. 11 is half-life. Okay, so that's the formula that you're going to use. And then number 10 is annual interest rate. Okay, but it says decreasing. So this one's just slightly different. Yesterday we wrote down annual interest rate as P times 1 plus R to the T power. Okay, because it's decreasing, you'll switch this plus to a minus sign. So this is the formula you're going to use for number 10. Okay. All right, let's do number 9 together, though. So we are investing 5,000. That sounds like a P. 5 years is T. 9%, 0.09 is going to be your R. And how much more will you make if your interest is compounded continuously than if it's compounded quarterly? So let's go continuous over here, and let's do quarterly over here. Okay. Compounded continuously is PERT. A equals PE to the RT power. Compounded quarterly would be A equals P times 1 plus R over N to the NT power. And in this case, when you're compounding quarterly, N will be 4. Because, oh gosh, N is 4. Okay, why are you doing that? I don't know what it's doing. Oh, I must have inserted this as an image or something. Okay, all right. Okay, N equals 4. All right, there we go. Okay. Oh, gosh. Okay, all right. I gotta go kind of fast. A equals 5,000 e to the 0.09 times 5 power. And if that is the case, I get, I'm working off a dumb calculator. Let's see what we get. E to the times 5,000. And I got $7,841.56. Okay, if I do this guy, I got 5,000 times 1 plus R is 0.09 divided by 4 to the 4 times 9, no, 4 times how many years? 5 years. Okay, I'm going to do some of this in my head, so 4 times 5 is 20. 0.09 divided by 4 is 0.0225. And if I add 1, that would be 1.0225. Okay. So I got that. I'm going to take that to the 20th power. And I'm going to take that times 5,000. So I just kind of did that really weird backwards. And I got 7802.55. Okay, so you are going to get more money, slightly more money, if you compound continuously versus compounding quarterly. And they say how much more? If I subtract those two, 7841.56, I get $39.01 more if I do the first route rather than the second route. Okay, so the other two formulas, the other two functions or section ones in that section, you can try to do with the formulas. Okay, all right, these ones should be short and sweet. I'm going to do 13 and 15. They just want you to switch them to the alternate form. So we need to decide first, is this a log or an exponential function? He is an exponent, so we want to transfer him to log land. And he will be log with a base of 10, and then the other two numbers switch places. So log base 10 of t equals, and this c plus d to go together, and they go over here. All right, now, log 10 is just log, so if you want to just write that as log t equals c plus d, you can do that as well. That means the same thing, because if there's no base, then we assume that it's 10, right? All right, this one is in log land, so we want to switch him from a log to an exponential function, all right? He doesn't have a base, but that means his base is 10. I'm going to put a 10 there, and this is going to say 10 to the y power equals ax plus b, okay? And that's all they want you to do, is just switch it to the alternate form, okay? So you can do 12 and 14. Oh, wait, 12 and 14. Ooh, is e's and ln's. So just remember that ln stands for log base e. Okay, so if you need to rewrite him as that first, you sure can do that. Okay. All right, evaluate each expression. Let's go to and do like 17 here. Okay, so they want us to evaluate this, but they don't want us to use a calculator. So what I'm going to do is I'm going to set this equal to x, and I'm going to switch it to an exponential function because my brain thinks a lot better in exponential functions. So this will say 9 to the x power equals 1 over 81. Okay. Now I know that 9 squared is just 81, right? But how do I get it to be 1 over 81? Well, that just flips the fraction. I know that a negative will flip that fraction for me. So x would have to be a -2 in order for that to become 1 over 81. Okay, so that's going to be similar to what you do on 16 and 18. Let's go down. Oh, gosh. Okay, let's do this ln one. Let's do number 20. Okay, they want us to put this together and write it as a single log. Oh, Lord. All right, number 12, or number 20. Yeah, let's do that. Okay, I'm going to go against what they say right now, and I'm going to break it apart first. So do you see where I have e squared and x? Okay, those are being multiplied together, and I'm going to break them, oh gosh. I'm going to break them apart into two pieces by splitting them up and making it addition. So I'm going to put ln of e squared over here, and I'm going to put ln of x over here, and plus is in between them because they're being multiplied. So that's how I'm going to separate them out. Okay, and you'll see the method to my madness here in a second. This guy, if you will be nice to me for a minute, this guy over here is kind of the same thing. E and y are being multiplied, so I'm going to break them up and I'm going to add. So this is going to be ln of e plus ln of y. And then I just have the -3 just chilling. Okay, now you're going to see how this works here in just a second. Okay. Write the given expression as a single log. Okay, great. Ln and e, you're going to cancel, but that means this 2 comes down, so I've got 2 here. This ln and e cancel, but in their place, it reduces to 1. So I have this going on. And I've got -3. Okay, because my ln and e's canceled and my ln and e's canceled. 2 plus 1 minus 3. Boom, boom, boom. And now I have ln of x plus ln of y. And plus in log world means multiply. So if I put those back together into one log, it's ln of xy. Beautiful. That's real nice. That's really nice. Okay. All right, next, let's talk about 20. Let's go to 21, and let's try to, they want us to expand this, so they want us to break all this stuff apart, okay? So multiply means add, and divide means subtract, okay? Now, this guy is the plus 1. He does not break down. That stays as one unit as z plus 1, so we'll get to that, okay? So let's break this down. Log base 3 of x squared. I'm going to change this multiply to an add and make it another log base 3 of y squared, or y cubed. And then I have division, so I'm going to have minus log of z plus 1. Now there's one more thing that I can do. If you will stop and be good. There's one more thing I can do, and that is to bring the exponents down in front. Okay, so this will be 2 log base 3 of x plus 3 log base 3 of y minus log of z plus 1. And that one doesn't have an exponent on the front, but he is completely expanded and broken down into all the parts. Okay, so there we go. All right, what shall we do? What shall we do? Let's do 25 and we'll do 29 and we'll see what we can do here. Okay, so 25. I want to cancel logs, and so I want to do this. Boom, boom, boom. But I cannot do that because here's my equal sign and I can only cancel one log for one log, right? So I have to find a way to combine these two together. All right, okay. So plus means multiply, right? So I'm going to combine those logs together, and that's log base 3 of, if I multiply 6 times these guys, I'm going to distribute him through, so he is going to be 6x minus 18, right? I just multiplied, okay? Equals log base 3 of 4x minus 8. Okay, and now I can cancel log and log. And I have this guy equals this guy, and then I'm just going to do my algebra, right? So I'm going to subtract the 4x. So I have negative 8 equals 2x minus 18. And I'm going to add the 18 over. And that is 10 equals 2x, and x equals 5. Cool. There we go. That one's done. 25. Boom. All right, 29, in order to do, this is an exponential function, right? In order to do this, I'm going to look at my two bases and say, can I make those to be the same number? Like 27, if you're just eyeballing 27, 2 and 8, I can write 8 as 2 to the third power, right? And I have that going on. So then my 2's just cancel, and I can say 5x equals 15, right? And I do all the things, right? But 5 and 7, I can't do that. So what I've got to do is I've got to log both sides. So I have log and log, right? And then what that allows me to do is bring this 2x down in front. So I've got 2x, and then I've got times log 5 equals log 7. Okay. And then I'm trying to solve for x. So I'm going to divide by log 5. And 2x is equal to whatever that big old decimal number is. And I got 1.2091. And if I divide by 2, I get x equals 0.6045. And that is what I get for 29. Okay? All right, so some of these on this other side are going to be similar to that. Let's just do... Let's do 32. And then we'll save 31 and 33 for tomorrow. Okay. All right. At what annual interest rate should you invest your money if you want to double it in 6 years? Annual interest rate. Should you invest your money if you, it doesn't say, I'm going to guess that we're just in the annual interest rate formula, which is A equals P times 1 plus R to the T power, but that's not what I want. If you want to double it in 6 years, using what formula? I don't want to do that. Okay, sure, let's go off of that problem. Whatever. What annual interest rate should you invest your money? Okay, we want it to double in 6 years. So the only information they give me is time, and that's 6. I want to try to solve for R. Okay, all right. And they don't give me a value for A, and they don't give me a value for P. So we get to just plug numbers in. Let's say I have $10, and I want to figure out when it's going to double to $20. Okay, it does not matter what numbers you put in here, because the very first thing that you're going to do to solve for R is you're going to divide by 10. And that's going to give you 2 on this side. So regardless what numbers you plug in, that's going to end up being like that, okay? And then to solve for R, this actually does not involve an exponential function. This is just algebra stuff. I'm going to get rid of the 6th power by taking the 6th root, okay? All right, and the 1 plus R is just going to fall out, and I'm taking the 6th root of 2. Ugh. Okay, I'm doing 6th root of 2, and that is 1.1225. Okay, if I subtract 1, that's just going to be 0.1225. So if I'm doing annual interest, I would have to have a 12.25% interest rate in order for it to double in 6 years. Okay, good luck finding an interest rate that's that high. That's going to give you a return of that, but whatever, that's what it would have to be. So there you go. That was a good start. I know that's a lot of problems left, and I've taken up a lot of your time, but that should give you a good start. We'll do some more tomorrow. Okay, goodbye.